Welcome back to the AI Ascent Podcast. On this episode, we have Niels. This guest is someone who I've had the pleasure of meeting several years ago, and I initially reached out to him on LinkedIn back in my college days, and we've had conversations about AI ever since. Today, we'll not only explore his current work at Union.AI, but we'll also be discussing his perspective on the frontier of AI. Welcome, Niels. Thanks for joining us.
Thanks, Luke. Thanks for having me.
Awesome. So to get in some of these questions, I know that you had spoken, we've had previous conversations about how you worked at Union.AI, and that's currently what you're doing. And so how is Union.AI paving the way, especially in the areas of GPU acceleration and open source development?
Yeah, so Union.AI is essentially a company that's trying to help builders get value out of their data. So that's a stated high-level kind of mission that we have. And notice nothing about AI in there. It's all about data. And I think that's something we were very thoughtful on in terms of how we frame what we do. Ultimately, AI, machine learning, whatever you want to call it, is all about, it's like data compilers, right? It's like data is the code that maps X to Y. And those two things can be very complicated. And you just have a function approximator that tries to extract the signal from that mapping. So again, it's all about data. And in terms of open source, Union.AI's main open source product is called Flyte. That's an orchestration system that you could use for a lot of different things. Data processing and ML being one of the two of the core focuses. So in terms of open source, that entire system you can just use for free, obviously. And Union.AI, the company, though, is trying to commercialize this. And we become essentially your infrastructure team. You set up the clusters, the resources you need on your own cloud. And we deploy Flyte there and then have a few kind of bells and whistles to make it worth your money. But in the open source, we're totally committed to really making this orchestration tool that's super flexible and ergonomic. Obviously, we still have a lot of work to do. But those are what we see as our contributions in the open source. We also have a few other products, Pandera, which is one of them, which I authored 4 or 5 years ago. So that's a data validation tool. And then UnionML, which is another kind of machine learning framework, MLOps framework built on top of Flyte and others. In terms of GPU acceleration, we don't really see that as our core competency. Like, I would say our core competency is infrastructure and orchestration. And how do I get those GPUs from some cloud in a reliable, repeatable, reproducible way? So that's our focus. Is we're agnostic to the tools that you use as a data ML practitioner. We just want to bridge the gap between how you get that infrastructure, right? Like if you use Google Colab, you're assuming you're like sitting on top of this stack that's probably very robust and very mature at this point. So, but if you want to have some kind of repeatable, scheduled, or some kind of process that you want to run in production, that's our focus, is making that as seamless as possible.
Cool, that makes sense. It kind of reminds me of Ansible in a way, some kind of an orchestration.
Yep. I mean, it's like, that's an overloaded term at this point, right? But the core problem it's solving is kind of constant throughout. So like Ansible or Terraform or like kind of infrastructure layer declarative tools are probably definitely sit lower in the stack. Flyte is it's built on top of Kubernetes. And so it's at the interface between infrastructure and infrastructure teams and data scientists and the practitioners. So it's that interface that we're really trying to optimize for, to make it as frictionless as possible, and make it scale to hundreds of thousands of nodes you're just executing casually. So that's what Flyte gives you.
That makes sense. And typically the customers that you have, are they larger companies, or are these smaller companies that where the people who are working on it are wearing a bunch of hats?
It varies a lot. The main thing with Flyte is that there are at least 2 users and user personas, I'd say, and maybe one person can encapsulate these 2, but it's essentially an infrastructure engineer. I guess I would also lump together that with kind of like DevOps, MLOps, basically the person like standing up stuff and maintaining stuff in your cloud, for example. And then the data scientist, ML engineer, data analyst, I'll just kind of like refer to those as data scientists for just compression. And that's where our Python FlyteKit SDK is quite appealing, because it's, really depends on your taste. Some people like writing orchestration code in YAML or JSON. Others like to do it in code. So FlyteKit is for the people who like to write code. You write your little nodes in your DAG. So nodes in Flyte are tasks, and then workflows are the execution graph that you kind of string together to different pieces. But sorry, to get back, so just to understand who uses it, right? But to get back to your question, it really varies. I mean, so Spotify is a user of Flyte, and the open source. So is Stripe. There's another company called Prenome. They do early cancer detection, kind of like multi-omics for cancer detection. So these are all various size companies, and we have like smaller companies as well, kind of building their I'll say like their products on top of Flyte. But since everything is gRPC available through API calls, you can build your own UI, and with Flyte powering it under the hood.
That makes sense. And in terms of the business offerings, I know you mentioned that Flyte, I think Flyte is the one that's open source. So how do you provide services on top of the open source tools?
So a lot of it is kind of the enterprise focus. So enterprises want resource-based access control. So you have an admin, you have a bunch of users in different teams. So as an admin, you care about costs, like which project. So in Flyte, you like structure things in terms of projects, domains, which are like dev, staging, prod, and then tasks and workflows. So as an admin, you can see like which project is consuming the most resources. So you look and you see it's like the deep learning team, and you're like, okay, this makes sense, right? So you get a higher level view of all the costs and compute, and like maybe quotas that you're not quite hitting, so you can like tell your team to use more compute. And then there are the kind of end users, because notice now that in the hosted platform, there's no infrastructure person, right? The customer we're working with may have an infrastructure person internally, and they kind of like vet things and make sure things are going well. But on the other side, there are like the data scientists and ML engineers who are writing those DAGs effectively and try to deliver whatever business value their objective they're like aiming to provide.
That makes sense. And what's new with Flyte lately? Have you deployed anything really interesting?
Yeah, we have a bunch of new kind of like beta features that we are polishing, but so a couple of them that I'm super excited about are essentially the idea of being able to declaratively say what your container dependencies are, and then Flyte actually handles building and pushing that to some registry. So just to back up, Flyte uses containers. So the way it's different from a lot of other orchestration tools is every node in your DAG is running in an isolated container. This might sound kind of ridiculous in terms of overhead, because you have to spin up a container, spin up a pod in Kubernetes, and you're like tracking a bunch of stuff, right? But what you get from that overhead is effectively very nice reproducibility properties, where you get, you have a big 1,000, 100,000, whatever node DAG. Like you have an error in one part, right? Your runtime environment is not conflated. It's not like this thing depends on the thing that failed. So you can like isolate that, you dissect it out, what Docker image, container image you used, and you can like reproduce that, assuming that it's idempotent, and you can like pass the same inputs to reproduce the error. So image spec is the solution to the Docker file authoring kind of pain of not everyone is super familiar with Docker. Maybe they just want to specify some pip dependencies. Image spec gives you that interface, and it's in Python code. I'd have to show it to you to like show what it really looks like, but that's one thing. Another thing is Flyte agents. So not to be confused with like RL agents or I guess LLM agents, but these are effectively a mechanism for creating plugins. So you can, for example, write a Flyte agent for Lambda Labs. And if you're familiar with that platform, you can get the GPUs on the cheap, assuming you wait long enough to get that A100 or whatever, or H100 these days. So Flyte agent is so this, just to be clear, this integration doesn't exist, but with Flyte agents, you could write a plugin system. It's basically a plugin system where you can write a plugin for some external compute resource. And this is Flyte's strategy for essentially being like the central like control plane or fabric, where you kind of might reach out to like weights and biases, or you might reach out to Lambda Labs. But what Flyte is as its core is keeping track of inputs and outputs, so data lineage, like making sure that what compute process and code like produced a piece of like an artifact, a piece of data or a model or something. So that's Flyte agents. The last one I think I want to mention, and it's not quite out yet, but it's eager workflows. So in Flyte, everything is, so workflows in Flyte are static. So there's like literally a static compiler, DAG compiler that Flyte uses to say, okay, this is your task. I'm stitching them in this certain way, and it just looks like a Python function where you're calling those task functions. But it's static in that you can't really change the shape of it depending on like some inputs, right? So historically, our solution to that has been dynamic workflows, where you get an input, say a grid, hyperparameter search like configuration, and then you do a for loop over that, say list of dictionaries, and then you can impact, shape the DAG execution based on like the grid, right? With eager workflows, you basically get Python's async syntax to be able to run your workflows completely without any kind of like static analysis, which you lose like the type safety there, but you get a ton of flexibility when you're writing your workflow. So it looks pretty much just like async Python.
Interesting. That makes sense. Cool. And also, I remember the last time we talked that you mentioned that you were employee number 1 at Union.AI. And so what's it been like to watch the company grow?
Yeah, it's been a great ride so far. Yeah, it was really early days where everyone fit in a Google Hangout. Obviously, you can fit a lot of people there, but it's like, you can, it's like 6 people, and you can kind of go around the room and say what's up. Yeah, the thing I really like about startups is everything you do matters. So it's like if you're, if you find an issue somewhere and it's all you just have to fix it. You might create a ticket and you might have some process at a later stage, but in the super early stages, you just kind of, you're there, you're sitting down, and you're like, okay, what do we need to do next? And so going from there to now, it's a larger team. It's about 40 people. We're seeing, obviously the growing pains of just having more coordination, and like the interactions, blow up in complexity, right? And when you have the more people you add. So yeah, it's been fun to watch. I mean, we're not done yet, right? So we're gonna grow more. And yeah, what else? I think I don't have any other thoughts there.
Yeah, that makes sense. Yeah, that's really exciting how it grew, because I know you were mentioning there were 5 co-founders and then you were employee number 1, and now it's already at 40 people. So sounds like some massive growth there.
Yeah, and it's been great to sort of be an end user advocate. So the background of most of the folks at the company, even today, are on the engineering side. It's back end kind of distributed systems engineers. So being the first data person there, and that type of persona being the end user was helped me sort of articulate things that I wanted. I kind of want to build the product I want to use, and that's sort of like my internal kind of mantra of how I go about personally, kind of day to day at work.
That makes sense. Yeah, I know you were mentioning, because in the early stage, especially with a startup, if you see something, it's kind of up to you to go fix it. So have you, now that it's grown to 40 people, you're not seeing that as much, and now you're a lot more focused on your area of machine learning?
Yeah, correct. So I don't really remember when I sort of made the pivot, but it's like every quarter or so you kind of reassess and you kind of say, okay, what do we need to do, and how am I uniquely positioned to sort of contribute in some fashion? So for me, that would be ML and sort of the education piece of going to conferences and doing workshops and stuff. So I like doing both those things. I kind of go through phases of building and learning and kind of synthesizing and teaching, but now I get to play in the sandbox of state-of-the-art language models.
Mm-hmm. That makes sense. Is Union.AI implementing generative AI right now?
Yeah, so internally we're sort of building up our capacity to configure our systems to train models at scale. Right now we're kind of at the fine-tuning stage, so we are kind of building our chops there. Fine-tuning is just a special case of full pre-training, right? Like there are new problems that come out of the full internet scale data training, but at some capacity, it's easier to start off with fine-tuning, because all you have to worry about, which is a lot to worry about, is how you fit these models in variable, very heterogeneous compute, and what's the cheapest you can go, and what are all the tricks you could use to train or fine-tune the cheapest model. So that's we're building that capacity just from a complete kind of capabilities perspective, so that we can provide examples and things like this for our end customers and users, both open and closed source. But I'm leading up the ML team for more of our product offering, and so I'm playing around with various internal use cases that we have that we can chat about a little bit, maybe vaguely, but yeah. I mean, the obvious ones would be kind of customer support, bot, right? Or some something like this, or like a documentation bot. So we have holes in our docs. You can like open up an issue and tell it which file to edit, and then it'll go create a PR, right? So that's an example of a company is probably doing this, and we would probably use this product instead of building it internally. But those are like some interesting project ideas that we're playing around with.
Cool, that makes sense. Cool. And are there any collaborations or partnerships that you're doing, possibly right now or on the horizon for Union.AI?
So in the past, we've worked with Databricks for an integration with their system. So that integration exists today. You can use that. If you have a Databricks cluster, you can, for whatever reason, you like using both. You can run your Flyte workflows and your Flyte code in the Databricks cluster. Current collaborations we have, we're sort of working with weights and biases for obvious reasons, experiment tracking tool, artifact store. So it makes sense for us to sort of hook into their system a little bit more. I'm not exactly sure. I think the nature of the integration today is more like first class, tighter integration with their, just like their core metrics logging service. Super useful. I use it every day. It's an awesome product. Also working with Memverge. It's this company that helps with spot surfing and right sizing. So spot surfing is when you surf on spot instances, and they have a whole system that checkpoints like the state of your entire system, and then moves it over to the next spot instance that's available. So you don't have to worry about like, oh, what state, like losing state across, recoveries. And right sizing would be, you're getting out of memory errors. Let's like through heuristics kind of figure out what the right memory requirements of your workload is. And the last one is the LangChain integration. So we're working with that team. We're basically, these partnerships are very interesting, right? Because a lot of them are happening in the open source. So it's all sort of like who builds what, and so and what like the interesting kind of intersections are. So with LangChain, we kind of an entry point that makes sense for Flyte is the data ingestion pipelines. So that's something we're looking into.
Cool, that makes sense. So going into some of the more general questions, given how quickly the AI industry has been moving, especially since ChatGPT entered the field just last year, what would be your advice for young professionals or students who are aiming to become a machine learning engineer?
So I think, there's kind of like the baseline stuff you need to do, which is a lot of self-study and a lot of like self-building and like Coursera courses, papers, books, like whatever your entry point is at, right? Like I think coming from a biology background, like I had to, like Khan Academy was amazing for me, just to get that confidence of, oh yeah, I can do math. Like I was decent in high school. Like I didn't take math in college, but I kind of get it. I can do the problems. And of course, from there, you just kind of go into textbooks, whatever your modality, preferred modality of learning is. I think that can be flexible. But I think beyond that, a lot of it is like, while you're training and practicing and like training and deploying models, it's very important to sort of identify your own pain points in this process and like build tools for those. So I kind of like to call this a kind of the meta problem, or like the meta issues that you come up with while you're doing the machine learning itself, right? And like an example of this for me is Pandera. It's like this data validation tool for pandas data frames, but now for others like PySpark and Ray or Modin and Dask. But that tool came out of just this pain point of this. I'm training these models, but the data is just invalid, and like sklearn's not going to catch that issue. It assumes that you've treated your data correctly when you're training your model. So that was something that just saved me time and gave me confidence to be like, okay, my data at least passes this set of checks. So I guess long way of saying, like, identify the pain points that you go through, and you don't have to make a full blown like library out of it, right? But make an internal script or like a gist that you save just for yourself. And then if you feel like it, you can kind of make a package and open source it.
That makes sense. Cool. And also, when it comes to these LLM models, we're obviously seeing these proprietary models, which are taking the lead because they're much bigger and these employees have so much money to be able to invest in them. But also the open source community has made great strides and seems to be gaining ground. So do you actually believe that the open source, well, not actually, but do you believe that the open source community has the potential to equalize or perhaps even surpass proprietary models? Or do you think proprietary models are always going to outclass the open source community?
I think I generally like to think about things in terms of ecosystems. Some things, right? Not everything, obviously, but like I think in this case, it's an ecosystem, just like with software more broadly, right? Open source benefits closed source, which provides jobs and like essentially is a benefactor to all these people who build more open source stuff, right? And at least where I've worked so far in my career, I can spend time in my free time just like building stuff on the side and doing side projects, side things. Of course, if you want to, I'm a fan of like agency and like not feeling like you need to be constantly hacking away. But in terms of equalizing, I think there comes a point where models are good enough for many use cases. And I think, like, just to be clear, from where I sit, the business value hasn't like even been tapped fully yet, right? I mean, there's business value expressed in terms of deals between companies like Microsoft and OpenAI. OpenAI is making some revenue, right? Could be a lot, and I don't know. But I guess my point more broadly here is that if you just think about the compute power in terms of humans in the open source working on these problems and just tinkering, right? Those will, many of those maybe won't scale, but some of them will scale. And the job of proprietary is to just like scale it, to its limit, given the resources, and you see what the best is. So it may sound extractive, right? Like closed source is just like taking open source's innovations. But I think, there's some interesting feedback loops, I think, of it is definitely asymmetric, but simply proving, like with a 4-minute mile, right? Just a closed source solution showing how good it is a proof of concept that for the rest of the open source people to be like, hey, let's try reverse engineering this thing, right? And like, even if you do have the resources and talent concentrated, and why I think kind of reskilling or education around this is really important. Like the more people there are in the open, it's like someone's going to stumble upon one of the 50 stepping stones we need to get to highly capable systems.
Yeah. Also, on that point where you mentioned that the potential of LLMs hasn't even fully been tapped yet, and so this kind of goes into the future of the job market, because initially when I started seeing like GPT-4 come out and I saw how good it was, I was thinking that very quickly certain industries would be transformed to the point where there wouldn't be that many jobs, such as maybe graphic designers for the computer vision and stuff. But so far, what it what we've been seeing is that there's just been even more of a labor shortage where there's even more stuff that needs to get done. And so are you seeing that as well? And how long do you think it will continue along that route?
I guess, sorry, just to clarify, you're talking about roles that have opened up now because of kind of progress in this space, or?
Yeah, well, how the introduction of tools like generative AI and these text to image and also text to video that are coming out, instead of causing job loss, it seems that they're only creating more and more jobs. And so that's just a very interesting point to see there.
Yeah, I mean, I think this is kind of veering out of my expertise, so I'm sort of opining here, but the kind of like the job destruction and job creation cycle, right? I think the thing we need to get better as, we as in society more broadly, is like the transition points, right? Like, who are the winners of the massive job creations and who are the losers of the previous generations, right? And it's not, if you look at it in aggregate, it's like, yes, more people are born and then they fill in these things, but like existing people with the existing skill sets, at least from my kind of hand wavy knowledge, it's like that transition is painful, and people are potentially left behind. So I think it's the sort of that on balance, as new roles open up, I think the important part is like helping through that transition process, and whatever that looks like, right? It depends on, whatever this is like a now social political issue, right? So whatever your political leanings are, it's like you'll reach for some tools to like help with this. If you agree that this is a problem, like you'll reach out for certain tools for this. But I agree with the general premise that probably on balance, there are so many unimagined roles, like sources of income, right? Ultimately, this is what it is. Like, how do I sell? Like, if we stay within the labor assumptions now, I'm like selling my time for money. Like, what is that I'm selling my time for? And is it LLM kind of maintainer, a trainer, a prompt engineer, a kind of like graphic designer kind of collaborator with generative tools? Like, there's a vacuum there that I have no idea. I can't even articulate what future jobs would look like.
Mm-hmm. Yeah, it's going to be really interesting to see how that whole thing plays out. And so on the topic of LLMs getting better and better, is it plausible to assert that we are progressing towards AGI simply by developing larger and more powerful LLMs? Or do you think that there's going to need to be some other fundamental changes to the way that these LLMs are structured in order to get us there?
Yeah, I think maybe it behooves us to define AGI in any discussion, right? So I can throw something out, you can refine it, or offer a different alternative, right? But for me, we use the term AGI. Obviously, it's overloaded, but I think we tend to use it to express like the limit of where this could go, and our imaginations go all sorts of places, right? It could be just human-like thing. It could be super intelligent being that we cannot comprehend. It could be like a friendly robot that helps you around the house and with your various tasks. So I guess to me, like, I'm interested in, I guess my take, I don't know if this is a silly take, but like I always go back to my original kind of training, which is biology. And I always frame this as a symbiotic thing. I mean, it's plausible to me that there's some catastrophic kind of scenario, right? It's within the realm of plausibility, but that's where LLMs, they operate in the space of plausibility, not like actual probability distributions. So, I mean, sorry, they literally operate within probability distributions, but like the tokens they produce are plausible, and hence why we have hallucinations, which is it's plausible, but it actually doesn't make any sense at all. But sorry, I kind of digress there. I think, so whatever you define as AGI, for me, it's like some non-existent today kind of entity that may be completely mechanical, partly biological. I don't know, but I don't imagine biology goes away in the system, so it'll be a very foreign, alien thing to us. But whatever that looks like, right? I don't think, like, it could be that tokenizing everything will work, right? We don't have to operate in the continuous space. I don't know if that's true, but assuming that you can, or assuming that would work, then like I think something that does something like a transformer is a very interesting, if you had to pick like a handful of small kind of architectures or tricks that we do, like probably something like transformers with an attention mechanism will be a significant component in this thing. But I think there are like a bunch of probably other modules that need to happen or need to be put together in a specific way to like give rise to, I guess, what I'll call something that's highly adaptive, can do a lot of different tasks at or beyond human level.
Yeah, for sure. Yeah, it'll be interesting to see how that all plays out. Cool. And so also in 2022, that was the year of AI image generation, where we had these huge leaps in performance compared to what we had previously. But AI video generation has lagged behind. Clearly, it's a lot more challenging since it involves putting together hundreds of images while also maintaining those long-term dependencies. How soon do you think that we will get to the point where we have very convincing text to video?
This would sort of be uninformed guesses, right? But I feel like for text to video, we don't have to innovate much in terms of architectures. I think it's like a lot of it is how to fuse different modalities effectively. And probably if you're working with text, like transformers make a lot of sense. And it's turning out to be a very flexible kind of API in terms of like the data types it can accept. So, audio to text, thought to text, video to text, and vice versa. Yeah, basically, neural nets will be sort of like this data translation layer between these different modalities.
Yeah, for sure. And another interesting point on that is that I remember GPT-4 it's supposed to be multimodal, but even up until now, we haven't even seen like the full capabilities of it, where we've seen that multimodal stuff. So it'll be interesting to see how that whole thing plays out. Like on the one hand, we're gaining these AI capabilities that are getting better extremely quickly, but on the other hand, it has to be tempered with all of this extra testing and making sure it's safe, and the release pattern of these tools can be completely different from like when we actually have them to the point that they're released to the public.
Yeah. And I guess one thing to add here is diffusion models, right? It's the thing that's powered a lot of really nice progress in image generation, and I think also video generation. So, and we've already somewhat figured out ways of combining attention with diffusion, right? So yeah, I think there's some very interesting kind of, I really like kind of learning about these new ideas, because the way, like, I'll watch YouTube videos and stuff, right? And sometimes, read the paper if I feel like it. But the intuitions are so nice, like diffusing coffee through hot water and like reversing that. And if you like go to small enough scale, it's all like just random kind of motion, right, through the like the particles through the water. It has like these nice imagery for you to really kind of like build an intuition for these systems. Same with attention. So maybe it's kind of like a post hoc thing where we slap a really nice narrative on top of the abstraction. But I think in many cases, it's like we're literally using our intuitions about how, an understanding of like physics and whatever processes in the world to come up with these architectures.
Mm-hmm. For sure. Cool. And so finally, the last question, this kind of goes into the AGI stuff, but is the relationship between computation and consciousness strong enough to enable us to build conscious machines? Do you think that consciousness merely arises out of complexity? Or do you think that the LLMs that will be coming in the next 3 to 5 years are not going to be anywhere near what we'd consider to be conscious?
Oh man, yeah, I don't know. Is the simple answer. I mean, if we use words in ways that we can't even really fully grok, it's like I'll know it when I see it, I guess. And I think a lot of people demand like proof in various ways, right? I think my standard's much lower. it's does it, how is it behaving? And as I watch it, how does it behave toward me, toward other, what seem like agents in the world, right? Like a plant is an agent. It just operates in a very different time scale than we do. And yet, I don't know, we typically don't ascribe consciousness to plants, yet they respond to signals. They make sounds when you like injure them, when you like cut into them, whatever those sounds mean. I don't know. It's probably not pain, or it might be, right? So I think it's sort of a gradient, and I guess one of my intuitions, though, is that pretty much all of our AI models today are as if you just live in a dark room, and all your life, all you're doing is looking at images and labels, just randomly sampled. And then all you're doing is seeing text, and you're predicting your next token. And then all you see in your hundreds of millions of compute time life. And I don't think that's the best substrate for developing consciousness, whatever that is. And somehow we deal with a completely correlated data set, right? So when you're born and to the day you die, everything that you've seen in your field of view, everything you've heard are like correlated in time. You don't get random samples of the universe, yet we do really well, and a lot of that is our kind of genetic endowment, like the evolutionary algorithm has worked a while to get these priors into us that like allows us to learn pretty well without the IID like data set just being shoved at my face. So I think there's something there that's I haven't seen any work on, at least, that just purely if you describe to me how ML models work today, I can say, oh, I don't know if they're conscious, because their experience of the world is random samples of data.
Yeah, Yeah, it's a completely different method of training the models. For humans, we have it we're continuously given information over time, but for them, they just get trained on a bunch of information that can be completely random. And with these LLMs, they get pre-trained with mass language modeling. So it's just randomly masking out some words and then having it make predictions out of it. So they don't
Yeah.
learn the same way. They don't, they don't perform the same.
Well, I mean, if we think of these as games, right? There's like the game of life, and there are these little mini games that you play, right, throughout your life. And a lot of them is like reading books. I mean, it's not random IID samples, right? But it's like you're sitting there and you're spending a considerable amount of your cycles to sort of like, you know, maybe predict the next word, but extract meaning from those words, imagine what the situation of the protagonist in the book is, so like doing a lot of work there. So that's, I mean, not that I don't think we throw away the current training kind of approach, but it's like, I don't know if anyone's tried this of like, what is just because to me, the question I think at this point is, it's like architecture, sure, but what is the data set that gets you to AGI? What do you like? How many gigs is it? How many terabytes is it? How many, and if it's not a fixed static data set, what is like the game engine? Or like what is the driver, like a game engine that produces the samples that you interact with in like maybe an RL setting, right? Like that's an interesting question that it could involve some bouts of like, oh, I'm going to go back to my old school kind of like random sample text next token prediction, right? But then I can like hop off of that and like, go to the internet and watch some videos as a AI model, right?
Mm-hmm. For sure. Yeah, it's going to be really interesting to see, how this the AI world plays out. I think we live in a very exciting time, and we're very lucky to be in the world of AI and to be able to watch this whole thing play out. So I'm excited to see what happens.
Yeah, for sure. I'm there. There's a while where I sort of had to step away a little bit. I got back into video games and just needed to like clear my mind. And then that was like kind of earlier this year. And after, a month or so, I'm like, okay, ready to get back in.
Yeah, it can be overwhelming sometimes just to see the AI advancements. One way I like to think about it is it's like like at a theme park, that ride that it takes you up really high and then it just drops you. And it's like that, like reading these research papers, it's that feeling of just getting dropped like every single day. There's something that just completely is like game changing every single day. So yeah, for me it was I think it's like a process of getting used to it, like getting used to the level of advancement, but then it just gets faster and faster. And I think I've learned to just kind of like let go a little bit and just let it go as it goes.
Yeah, and at least one of my tactics for my mental health is to just see it as a noisy process, right? So like these innovations, like they're definitely step changes, they're definitely incremental improvements. And then at some point it becomes mind-blowingly kind of like better. But it's good to kind of take a step back and live life a little bit. And then just, a lot will happen in a month, but you can sort of get the gist of where things are heading, what's the current state of the art, like what's possible, what's still like open questions. So it's like a microcosm of just checking your feeds or checking your training runs as the loss goes down. It's just like you don't have to refresh every every 10 seconds, you can come back tomorrow.
Mm-hmm. Definitely. Cool. Awesome. So that was all the questions I had. I'll put the contact information for you in the description. That way, if anyone wants to reach out, they can reach out to you directly. And I just want to thank you again for coming on the podcast. It's been really great to have you on and talk about these topics.
Awesome. Thanks so much, Luke. Had a lot of fun.